Might cut that out.
No, I'm putting that in. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 340, the best programming language, space surgery, and hacking two 3D printers into one. This week in Hackaday News, Tuesday we announced our first round of speakers for SuperCon. If you don't have your tickets yet, go get them. And if you don't know why you want your tickets yet, go look at this list of speakers. It's absolutely fantastic. And it's just under, it's somewhere between a half and a third of the talks we've got scheduled.
There's always some amazing speakers. I never get to see any because I'm busy running the solder challenge, but I always hear good things. Watch them on YouTube.
Yeah, right. I get to see a bunch of them because I MC a bunch of them. And so, it's a great excuse to just sit there, chill out, and watch some good talks. Can't beat it. As usual, it's quite the gamut this year. We've got hardcore testing of FPGAs by hitting them with gamma rays. We've got photography. We've got bling. We've got a professor who brought badge life to his kids. We got Joe Fitzpatrick, who's working on poking at chips and seeing if you can use one signal to make different chip peripherals do different things. There's different levels of techiness, there's different levels of nerdiness, and then this all spread across a whole bunch of different fields. Looks like it's going to be super. I'm getting excited.
Did I hear we have something Star Trek themed this year, or are we not ready to talk about that?
Sci-fi themed. Well, I think we're not ready to talk about that yet.
Okay, you can always cut that out.
There's definitely a bit of a sci-fi theme going on, and probably a spoiler to go along with that for later. So we'll see. But stay tuned to Hackaday. In the next couple weeks, we will talk about our keynote speakers.
Oh boy.
So yeah, if you haven't made up your mind yet, oh my God, just go. SuperCon's awesome. It is the annual Hackaday gathering of tons of birds of a feather. It's just a great place to talk about your crazy projects with people who are also doing their crazy projects.
Well, that's the thing. It's a nice place to go and you can feel like a normal person, right?
Yeah, right? Yeah, it's an astoundingly bright and varied crowd. And you could talk with anyone about anything, for a weird definition of anything.
What other room can you yell out? Does anybody have an op amp and 5 people will approach you, right? So that's
exactly. Rail to rail, or do you have a negative supply?
Exactly.
So anyway, really excited. Stay tuned next week. Tuesday, we will put out the next round of speakers talk, and then probably after that, the badge reveal, and then probably after that, the keynote. If you are on the fence, hopefully one of these posts will kick you over to the other side. Oh, and did I mention there's good food? There's an awesome badge. Oh, my goodness.
There's usually music.
Friday night, we have a costume party Saturday night. It's pretty much unbeatable.
I think I'll be dressed as a beleaguered Hackaday author.
Boo.
That's my costume.
Boo. So Halloween falls Friday night. We're having a costume party. The ostensible theme is sci-fi. And I am stoked to see what kind of sci-fi stuff people have. I don't have anything sci-fi. I don't know what I'm going to dress up as.
Well, Tom had a uniform tunic on last year, but I think he may have been the only one. But we all thought it was cool. So
Tom's hardcore. He's got a bit of the prop maker in him too. So he'll have a bunch of things.
He does.
This is a journey into sound.
What's that sound?
What's that sound?
This week is an Announce the Winner week, which means last week we played the sound for the first time. People got their chance to guess. Now it's Al Williams' chance to guess, and we'll hear if he got it right or not in real time.
Oh, great.
And pick among the right answers for a Hackaday Podcast t-shirt. What do you think?
I think it's something rotating and cutting, and so I think it's a printing press printing either magazines or newspapers.
Congratulations. That's exactly what it is. It's an old school printing press.
You got to remember, my dad was a printer, and I've run a printing press many times in my life, so that was a little unfair, I got to say.
Damn it. How was I supposed to know that? How was I supposed to know?
That sounded very familiar, very familiar.
Yeah, for sure. Tom got it too. And I don't think he has any printing history in his family, but I could be wrong. Let's see. A number of our listeners got it right. There's actually, who was it? Shirtless guess was, could this finally be the sound of a printing press? There have been people guessing printing press every time anything vaguely mechanical comes up. It's a slide projector switching slides in the carousel, and they're like, is it a printing press? No, it's not. This time, yes, congratulations, it is. We got, what did we get? Oh, 40 answers, 20 of which are right. So 50%?
Wow.
Yeah.
Wow.
Well, 19 are right, but 19 means I get to roll a 20-sided die, so I'm pretty stoked about that. Here we go. Ready? 8 is a printing press from Absolutely the Best Podcast, a work in progress. It's a secret plug for your podcast. That's nice. This one's in the answers every week, so congratulations. Absolutely the Best Podcast, if that is your name.
Could have just had cruel parents. You don't know.
Get an email out to you shortly and we'll get a t-shirt sent. Everyone else out there, stay tuned next week for your chance to hear a brand new sound and guess what the heck it is. All right, so let's start talking hacks. Actually, this week I wanted to start off with an article we covered from IEEE Spectrum. Stephen Cass wrote it up, and our very own Al Williams wrote the daily for us. Ask Hackaday, what's the top programming language of 2025? And I guess IEEE Spectrum's been running this most popular programming language thing for quite a while now. Surprise, surprise, most popular programming language according to their varied indexes, which are like searches and job searches and employers looking for people wanting a job and new books published on the topic, et cetera, et cetera. They take all these together, combine them into one big number, and tell you what the most popular programming language is. And drum roll, please, it's... Al is crying over there. It's Python. Yay!
I was holding out for fourth, but, again, not again this year, but next year. Next year's fourth year.
Al doesn't really like Python all that much. So I'll just go down the list. It's Python and then Java with about 50% of the share of Python, C++ at about 37%, SQL 33%, C#, 29, JavaScript, TypeScript, C, Shell, Go, R, PHP, Kotlin, Rust, Dart, Swift, Ruby, HTML. Bringing up the absolute rear with kind of what looked like under 1% of the popularity of Python each. Lisp, Pascal, a language I've never heard of called Raku, Clojure, which is kind of a Lisp, and Erlang, which is the least popular of the languages that were popular enough to make the list, which fourth, of course, wasn't. So you're not even on the page, man.
Story of my life.
But yeah, I don't know. When I look at this list, and I think you said this in the article, a lot of them are kind of variants of each other, and I don't know how you count them as different languages. Like Arduino is in there, but C++ is in there, right? And C's in there, but C++ in there. And C#, I don't actually know anything about C#, how similar it is to C or C++, but they're seeming to go for it. Objective-C, that's in there too. Like if you lump all these together, C is immensely popular, like the C family of languages. But then if you do that with the JavaScript family, you throw JavaScript, TypeScript, Kotlin's one of those too, isn't it?
I think so.
You throw all those together, you get something that's kind of 60-something% as well. So I don't know. Java's number 2, but if you kind of lump some of the family languages together, I think they get up ahead of Java. So either the JavaScript family or the C family, depending on how wide you're willing to cast that net.
And they also did the reverse, right? They imploded some things. So like there's assembly language on there. Well, what kind of assembly language, right? So
that's true, right?
1% of assembly language, well, okay, that means it's, 0.5 x86, 0.4 ARM, and, 0.1 stuff nobody's seen for 25 years. But, speaking of assembly, I thought the real interesting part of this, because they've done this for years, I usually glance at it and it's not totally surprising. But what I thought was very interesting was they were talking about how the process is now kind of poisoned and they're afraid they need a new one. And of course, it's because everybody's favorite topic, AI, right? The narrative was, used to be, you'd say, I went and looked on Reddit and I went and looked on Stack Overflow, and there were 200 questions about JavaScript and there were 80 questions about C++. And then I go grab the Google search statistics and, 1 million people asked about this language and 500,000 people asked about that language. So that kind of gave them some feel. But now, and I think especially depending on the language you're talking about, people don't go to Google and they don't go to Stack Overflow. They go to ChatGPT or they go to Claude, or even more so, those things are getting built into your tools, which I have mixed feelings about, by the way. And so I don't ask anymore. I just ask some random AI agent somewhere. It answers me, and there's no record of that for them to see. So in theory, you could have something that's way more popular, but all the activity is sub rosa, if you will. And especially as we see more and more of that built in, I actually noticed Visual Studio Code now does a lot of that for you. And it's surprisingly good, but it also annoys the devil out of me. I got to go figure out how to make it like only when you ask or something, because you start typing something and it goes, say, you populated array element 0 and it's a 100 element array. So I've just put this shadowy looking group of things in there for 1 through 99 for you. And you're like, okay, that wasn't really what I wanted, but thanks, and then you got to, well, you either have to figure out how to get out of it without making the shadow real, or you've got to figure out if you want it, how to make it not be a shadow. Because I get it about 50% of the time. You go, oh, that's what I wanted. And you go, shit, where'd it go, right? Or you say, I don't want that. And then, oh, there it is. I made it real. So I think that was real the takeaway here. And they had a very interesting take. I don't know if I agree or not, but I think it's an interesting point was, they've made the prediction that the AI stuff, which presumably will only get better, is going to make it for programming the way high-level languages did. So, I'm old enough, back in the 70s or 80s, if you were two programmers talking, you were, I've got a Z80. Ooh, well, it's got 5 extra instructions and it's got, the extra register set and all that. And you knew all those details. And even if you were programming in something higher level, you knew that, and it was probably important that you knew that, and it made a big difference. Now, you write C code, and unless you're doing something very specialized, you really don't care much if it's x86 or if it's ARM or something else, PPC, or, what it's kind of abstracted away from you, and only a few people care in a very few instances. So they're positing that as AI gets more prominent in programming, you will care less about what high-level language it delivers, and you will more care about, I'm going to specify my requirements. I'm going to do test cases to make sure it does what I want, or I didn't regress when I added something, or things like that. So it's going to be more a systems engineering task and less of a programming task. I definitely feel bad about that. What I can't decide is if I feel like that's really true or not. But I think we lose something every time we take a step up on the abstraction ladder.
Yeah, I was thinking about that one too. At some point, they want the large language model to be the compiler. Is that what they're that sounds like what they're almost getting at, right? They're like, you're going to get rid of the intermediate computer languages and go straight from here's the description of the problem to here is are the machine instructions to do it?
Or it doesn't matter. I mean, it's just like like the original C++ generated C code, which you then ran through your compiler, right?
Right, into some meta language in the middle that then you'll compile.
That's his point is, if I'm going to say blink this LED, I don't care if it writes assembly, if it writes C++, if it writes Java, if it writes Lisp, writes Forth. I don't care as long as it's in something that my computer knows how to process, right? One of the points he made, which was kind of interesting, I guess Stephen Cass made, was that may make it harder to get new languages introduced, right? Because
right, sure.
If you don't care, then you don't care, right? And
yeah.
what is it? Who cares? It's like assembly language. Now, if you come out with a new processor, no one says, is it instruction set compatible with, everybody says, does it have a C compiler? If it does, well, then I can get Linux running on it. I'm done. I just compile all the stuff. I think you could wind up very easily in that situation where you say, oh, here's a new language, and everybody says, who cares? The other thing is that leads to a kind of dragon and an egg problem where you have a new language, the AI wants to learn it, but there's not this huge body of sample code because nobody's using it.
That's the thing with these large language models anyway, is that, you train them on existing data, they learn the probabilities, they compute their weights, and then they spit it back out. And if you do that with something that doesn't exist, good luck.
Or or didn't exist. So that's the thing, right? If you want to teach a computer C now, there's billions of lines of C out there
Yep.
publicly accessible. But what if you just had the K&R white book and you said, okay, train on this? Well, that's going to be a disaster, you
Right.
would imagine, right?
Oh yeah, 100%.
100 examples, and they're great examples, but it's 100 examples and it doesn't cover everything.
The reason Copilot works so well is that it's got, all of GitHub and all of Stack Overflow and all of everything in its training set. Like that's kind of a no-brainer, but as soon as you start to do something novel, then it's game over. I really like the take in this one that, all languages basically do the same thing at the end of the day, right? And he brings up the example of go-tos, and nobody writes anything that uses go-tos anymore these days. But if you look at the assembly language, if you look at the machine language, it's all just jumping here or there, right? Like you can't get away from go-tos at the fundamental level. The question's just how well does the language abstract away these things that make it easy for you to screw up, right? And so the language is just kind of this defoot gunning layer in between what the computer needs and what the person likes to type. And so then if you look at this proposal that we use large language models to go from a project description to operating code, that's just like a re-foot gunnerization of insane proportions. I love the idea. What hallucinates 10% of the time? Introductory programmers? No, large language models, So I think it's going to be interesting. I think it's going to be a fun time if this vision comes to play. I think it can't, honestly, but we'll see. We'll see.
Yeah, it's hard to say. And of course, it's one of those things that's very tempting because, the corporate overlords are like, oh, we can fire all these difficult, expensive people and replace them with a computer. Yay, right? That's what a win. So I just don't know that it's quite the same thing. And like you say, there's always going to be the edge cases where human judgment's got to be better. Back to your point that they trained on all the GitHub and probably Hackaday.io and everything else, we should give away T-shirts at SuperCon that says, I taught ChatGPT how to program, and we could all wear them, right?
It's probably about as meaningless as having your code in the Arctic vault, but I'm down with that.
Exactly.
Yeah, we'll see. We'll see. I love the idea of if a computer language is there to make it so you can't make mistakes, what you do is you put a black box in between you and the results. I think that's brilliant. But like you said, maybe it's all going to be about writing test cases. Again, that puts the foot gun on the other foot, right? It means that instead of writing in a language that's supposed to make it safer for you to express your ideas, you just tell the large language model what you think, and then you have to write all the test cases to make sure it isn't doing the wrong thing. And that's a weird way to program anyway.
Well, oddly enough, it's not that weird. It's the way it's done in giant projects today, right? I mean, you've got some architect that probably produces UML or, now they've got the, model-based, whatever, and they do a model, the requirements, somebody goes and generates test cases, somebody else writes code, but if you do it right, theoretically, by the time you go to write code, you look at the UML and it's just obvious, and in fact, a lot of it gets code generated out of UML. I have mixed feelings about that too, by the way, but
Yeah, yes and no though, because when people are generating the requirements and when people are generating the UML, you can kind of foresee where the problems are going to be. And so you can write the right test cases, right? Like writing the test cases for those is actually kind of hard work. Thinking
yes,
about all
very
the
hard.
ways it could go wrong. But adding LLMs into it throws a real left field. They can go wrong in ways that you can't even imagine. Like, it's not like, oh, I got a test for the person's going to forget that it's zero indexed and they're going to write over the edge of the array or whatever. I mean, that was a dumb example, but we know that people do that sort of thing. And so we are watching out for it. And so it makes it easy to write the test cases. A, the ones that do the right thing, but then B, the ones that guard against doing the wrong thing. Whereas large language model, it's going to hallucinate programming language constructs, throw them in there. You didn't see that coming. You didn't write the test for that.
Well, and that's the thing too, is if you've ever worked on a program like that, writing good requirements and good test cases is insanely difficult. So when it doesn't work well, it spectacularly explodes and you have horrible problems. So at least in a case like that, you might have a smart programmer at the bottom going, this is garbage, but I'll just make it work and meet the requirements and pass the tests. with this, if you go open loop on it, it's not going to be, like you say, it's not going to be pretty. So I
Anyway, I
definitely
think it's gonna be fun.
have mixed feelings. Yeah. Yeah. I have a longer story, but it ties into a Hackaday article I'm going to do, so I'm going to pass on it. But it's definitely alarming. I think that's a good place to stop it.
Can't wait to read about it.
My first pick this week, Robot Bartender is the Life of the Party by Ben Cokes. So, everybody seems to think they want a bartending robot, which you can read into that what you want. But we see a lot of bartending robots. What was interesting about this one is it was some surplus 6DoF industrial robotic arm that had been set to Chinese. And from the way it's written, I assume that he doesn't speak Chinese. And of course, like many things like that, no documentation, real hard to find anything about it. So he hacked into it. Even then, that's interesting. It's fun to read, fun to watch, but that really wasn't what interested me. What's interesting to me is, I spent years as a kid going through ham fests and swap meets and things like that. And you see, oh, here's this oscilloscope I can get for $100. But of course, some big company paid $15,000 for it 5 years ago, and now it's garbage, so I can buy it. We're going to start seeing that with all these industrial robot arms, right? They're going to start showing up, and you can just basically get them for the cost of hauling them away as they replace them with newer and better things. So it got me thinking, what could you do with that other than obviously make a great martini or whatever your drink of choice is? So it seems like there's got to be other things you would do with an industrial robot arm. That'd be a good Hackaday, ask Hackaday, right? What would you do with a 6DoF arm? That was what I think appealed to me out of this article, was not so much the very good technical work that went into reverse engineering it and then working it out to do the bartender part, but it was actually the idea that, wow, these things are starting to show up where you can get them for, pennies on the dollar. What are we going to do with them?
This is totally the story of I just bought a surplus robotic arm. I know a couple people who have done this on their own, and you get this really big industrial robot arm. You bring it somewhere. First you have to find space for it. If you're lucky, you've got the garage. You put it in the garage, and now it's like, oh crap, now I have to make it work. And so you spend like days, weeks, who knows how long, working on this thing, and then you get it to work, and then you're like, oh crap, what do I want to do with it? I love that. I think that's fantastic. This one, I have to say, serving drinks the way it's doing it is actually a pretty cool and difficult problem. So he's got the drink ingredients set up, and they've got actual dispensers on them, and the arm grabs a cup and it pushes them up into little dispensers that put out measured amounts of each ingredient into it. Like, it's actually mixing it the way a person with an arm would, which is pretty cool. If you look at the other cocktail robots we've seen on Hackaday, usually it's pumps, right? And it's mixing things, and there'll be some bling and other stuff, but it's not as kind of, quote, simple, as brutal as just a robot arm making you the drink, like there was a person in there doing it. And I think that's kind of fun about this one.
Well, I'll be honest with you. I've seen it before, actually, at a casino, and I assume it wasn't a one of a kind. I assume it was a commercial product. But I've always thought, when I see that, I think, well, that's great because it's very showy, right? It goes and grabs the bottle and tilts it over and all that. But on the other hand, I'm thinking, well, if you were really wanting to, it's the old Cylon thing. Why do Cylons look like people? If you really wanted to do a great robotic bartender, it would have nothing like that, right? You'd load a glass up and, it'd go under drinks, and you'd open a valve and let the drink fall into it and then stir it or something, right?
Exactly.
There's a dozen ways you could do that don't involve human looking things. It's just, that's not cool. That's the coffee machine where the cup falls out and the coffee shoots into it and you open the door and take the coffee. That's not sexy. Couple of arms manipulating things like a human does, that's much more interesting. So I think it's been done. I think it's probably, I'll bet he did it for a lot less than what that casino paid to have it done, is my guess. I'm just guessing.
I mean, I'm sure it's been done before. If you had a robot arm, what would you do with it?
I just want it to scratch my back. That's it.
That's not bad. I kind of want one to do, position a camera around my workbench. So if I'm doing a project or something, I can have it take a picture from this angle, take a picture from that angle. But that's like basically lazy man's tripod.
Well, I always say the reason I was so fascinated with 3D printers, I'm going on 13 years of 3D printing now. The only reason I'm so fascinated with that is I can imagine stuff that I can't build, but I can imagine it and make a 3D printer build it. So maybe that's what I want with the arm is like I could have a board and a picture of it, and I just say I want to solder here, and it solders for me. That'd be great.
Oh, there you go.
Have a solder button, a desolder button. You just push a button, and there it goes. So
Yeah.
Hackaday invention.
I'm jealous of all these people who just find discarded robot arms around them. I'm going to have to keep my eyes open.
One of my big regrets, I went to an auction at a university one time, and they were selling a transmission electron microscope that looked like it was from about 1955.
Oh,
But it didn't have the vacuum system with it, and I don't think it had the high voltage. It was just the column and the control. And I was like, there's no way I can dedicate a third of my house to this thing and then still have to put all that stuff together. But and I mean, you could have literally, if you'd offered them $1 for it, I think that would have been sufficient. I don't think they were so anxious to get rid of it. So surely you have a one that got away surplus story, right?
I don't know. I either don't let them get away enough, or my goals are smaller.
Well, that's the thing. What would I even do with a transmissive electron microscope? I don't know. I don't even want one. Scanning electron microscope, I got use for that. But
Yeah, I definitely look at stuff.
what would I want a TIM for? And then plus, you'd have to have a way to do the microtome and the sample. I mean, yeah, that would have been a gigantic project.
But I think that's why you do it, right? I think it is the gigantic project. It's the reason you do it. Otherwise, just walk away, man. In fact, run.
Wait, you write for Hackaday and you have time to do a gigantic project?
I don't at all. But
Kind of my point.
I'm knee deep in the badge. That's a gigantic project. Yikes.
Yes.
All right, my next hack comes from Moritz Klein. It's a video, the making of a minimalist analog drum machine. And if you haven't been watching Moritz Klein's building DIY synthesizer video series, you are in for an absolute treat. He's been doing this now for, I don't know, I've been watching his videos for at least 3 years now. And they're just getting better and better and better. And he's kind of going through a lot of old school analog and analog digital hybrid synthesizer things, but stripping them down to the absolute minimum. And what's really cool about that is he explains the circuits and how they work. And so, even if you're not interested in audio or synthesizers, there's a lot of learning here in just terms of analog circuitry, straight up analog electronics. And I think that's really cool. In this case, he's building a drum sequencer and starts off with a shift register. And I did the series on Hackaday, Logic Noise, and I made a shift register sequencer too, and mine is half as cool as his. So, A, super kudos, but B, the idea of a shift register as a sequencer is awesome because it's just if you think about a shift register, you put in a bunch of ones and zeros at one end and you give it a clock and they move on down one at a time. If you were to sample at one point in this, you would get the same pattern out as you put in. If you feed this thing's output back into its input, you get something that just kind of loops around over and over. So you get a pattern of ones and zeros that feeds into itself and just keeps playing. And that is the sequencer. So he hooks this up to like a bass drum and it goes boom where there's a 1 and it doesn't go boom where there's a 0, and you just type out. He's got another little bit of circuitry that, you press a button and it pulls it high. So you get a 1 in that part of the shift register, and one where it sets it low, and so you can cancel out old hits and stuff like that. And so he starts with this really kind of very super fundamental. It's a CD 4015 shift register IC. And he makes up an entire sequencer out of it, and he adds accents to it. And, he does it in a way, he calls them smart accents, but really he's got kind of, instead of making some hits arbitrarily louder or quieter, he just runs a triangle wave underneath it. So some of them are louder and some of them are quieter. And the triangle wave isn't synced with the shift register, so it can kind of phase in and out of it. It makes fantastic patterns. And then he just keeps elaborating on this, throws in pulses. He pulls some of the pins off of the shift register and throws them into an R2R DAC so he can get, like 16 quote analog voltage levels out of it, and uses that for a different accent track and stuff. What's fun about this is everything is very simple analog electronics here, but you watch him play with it and you just understand how much fun it can be to tweak around with these kind of circuitry. And if you have a real drum sequencer doing these kind of polyrhythm things where you have one pattern going in the accents and a different pattern going in with the kick drums. Like he does this just automatically, just because he's got an oscillator that isn't synced to the other oscillator, and that gives it to you for free. He just gets a wide variety of really cool effects for 3 chips. He decides to make a bass and a snare, so then it brings the total to 5 chips and a bunch of capacitors and resistors. Absolutely worth watching if you're into analog electronics or synthesizers or both.
Well, these always interest me because I'm an old magazine guy at heart, right? So when I was a kid, before the Altair 8800 came out, and I guess the Mark 8 in radio electronics, this was always what people were building, were these analog synthesizers, and they had become more and more ornate. And you had, 48 patches and all the jacks that could be cross-circuited and everything. And then when the microprocessors came out, that seemed to just kind of really put a damper on that. I mean, of course, obviously some people still did it, but it just didn't have the cachet that it did before. So if you ever go look about 1974, 75 in the old magazines, they're just full of this stuff. And like you say, it's a great way to visualize what's going on, or I guess visualize isn't the right word. Audioize, is that a word?
Yeah.
Audioize what's really going on in these circuits. I always say, electronics is hard because we're one of the few kinds of people who can't see what we're doing. If you build a bridge, you can go stand on the bridge, jump up and down on it, shake it. If you're building a gear train, you can look at it and poke at it. We look at stuff and it doesn't mean anything. It's the electrons running through the wires and the components change things, but it's not obvious in a just a look at it kind of way, which is why we got to have oscilloscopes and things like that. But this audio stuff can give you a lot of insight into what's going on. So it's very cool. Also, I would be remiss if I did not mention that if you look at the title page to the associated YouTube, that is brilliant. It's like a little schematic, but instead of the symbols for the components, there's actual components, and it's just very neatly done, very artistic. One of the highlights to this was there was a gigantic PDF manual for it, and that's really impressive. And I've noted that lately we've been seeing more and more of that, where people are really going the extra mile to document these projects, which selfishly, from writing it up on Hackaday, that makes it nice. But also, I think it really makes it nice if you're trying to duplicate something like this, to have something other than, a YouTube video and 4 bullet points on a web page, when you've actually got something concrete that you can look at that really does a good explanation. We've seen a couple of projects lately that have just been crazily well documented. That Entron, which was oddly enough another synthesizer. I think that might have been this week, or maybe it was last week. And also one I've got coming up later has just insanely good documentation. So really, congratulations to all these folks that are taking the extra effort to document what they're doing for everybody else.
Part of the reason it's so well documented is that he's got a deal with kind of boutique synthesizer company, Erica Synths, and he's making this and a lot of the things he's done in his videos as projects for them. And so you can actually buy the parts to make this, and you get the instruction manual and you can put it all together yourself. But he's also got it all completely documented for you in the video, and you can just pull down the documentation one way or the other. It's a total win. And like you say, DIY synth stuff used to be the big deal, and maybe microcontrollers killed it off. I think we could argue about whether they killed it off or they just pushed it up a level of difficulty. I'm not so sure. But these kind of old school analog circuits are really, really fun, and it's just a different way of thinking. I've got these 2 waveforms. I need them to sync up with each other so that, they fire off at the same time. What do? Well, I get a transistor and I drain this capacitor out so that they're at the same level of charge at this point in time, right? It's really old school analog electronics.
Well, I mentioned earlier I've been doing 3D printing for 13 years, and my next pick was cannibalizing 2 3D printers to make a new 3D printer. Improved 3D printer cannibalizes 2 older printers. I guess that's the real word. The hacker in that case, Urbis 3D, had, as too many of us do, old printers. And I'm always very interested in that as stuff progresses, I hate to say it, but it becomes less interesting to me. When you can just buy something and it works and you don't have to take it apart and understand how it works, and why do I care about that, right? So I get the idea that you hold on to these old printers, and I get the idea that you want to move them into some new state of being that's better. And, as you know, I've done that myself a couple of times. So I thought that was really interesting. He took two Ender 3s and kind of merged them together. And it just shows you, I mean, those used to be fairly common machines that were really hot. But now, well, they're bed slingers. All the new machines are Core XY, and all the new machines have this and this and this. So it's very interesting that even just a printer that's a couple of years old, you can really say, well, but now there's all these new things that I want to do. Now, me personally, I tend to just add to them, but he actually just tore it apart, bought a few new parts, and wound up with something that kind of suspiciously looks like a Voron almost out of the pieces and parts of it. So I thought it was really well done. It's one of those things where you might not actually duplicate it because you probably don't have exactly the same things that he had. I think that's a really common idea. And I see that with the PC world too, right? I've got PCs that I've kept going for 20 years by, it's the PC of Theseus, basically. Is it really the same PC? Well, I don't know. It's changed. Everything's changed at some point over the last 20 years. But when you buy a machine now, well, it needs a sound card. No, it doesn't. It's already got a perfectly good one. Oh, it needs a network card. No, it's already got a perfectly good one built into it. It's a lot less fun, right? I used to really enjoy being able to go, oh, look, I figured out a way to make it a little faster or a little better. Let me go do that. And so sometimes I enjoy working on the old stuff just because of that, because you can, in fact, aim for that current state of goodness, if you will, and try to make it a little bit better. And I think that's kind of what this project embodied, and it just looked like a lot of fun.
It's funny. This is kind of the opposite of the computer of Theseus, right? Like the ship of Theseus is you keep changing parts and it still looks like the same ship, even though all the parts are different, right? It's like
Yes.
my grandfather's axe. I changed out the handle. A few years later, I changed out the head, but it's still my grandfather's axe, right? And this one, it could be made up of two Ender 3s. It could be made up of I don't know what. He could have just gone out and bought the aluminum sections and the V-slot and built it from scratch. This is just like he happened to have some Ender 3s because it ends up being a totally different printer, right? And you said this. It's basically like it's an XY Voron clone. That's a nice looking printer too, actually. I mean, I won't lie. It's a sweet design, and making use of some of the junk printers you have around the house, that's not a bad thing to do. I mean, you've got a bunch of stepper motors. You've got a bunch of useful aluminum extrusions, a heated bed. You've got all the stuff you need to make a better printer. He goes out and he does end up splurging on some nice linear rails and some, fancier belts and stuff like this. So at some point, he's also just buying himself a new printer. But it's a sweet design. It's nicely built, nicely put together, and it does do a lot of reuse of some of those parts. So if you got some Enders kicking around, or if you can pick them up super cheap on eBay, which you probably can, you could think of them as a kit of parts rather than a printer. You'll be on your way.
I had to greatly restrain myself the other day. I was in a cheap resale shop here in town, and there was a monoprice, like Maker Ultimate in pieces. And I was like, and they wanted, $10 for it. And I was like, I don't need another printer. I'm not going to embarrass myself by saying how many printers I have in the shop right now. And I certainly don't need the parts. And I thought, well, maybe some kid will buy it and that'll get them, I have this fantasy that it went to a good home where it really helped somebody instead of me just hoarding more parts for the apocalypse.
That's probably the right thing to do.
Yeah. It took a lot of restraint.
You're a good man. You're a good man.
But that's how common this has all gotten, is that you can go into a thrift shop and there's a 3D printer in it, right? When did that happen?
No, you have better thrift shops than I do. Transmission electron microscopes and 3D printers. I need to step up my thrift shop game. All I can find are musty old shoes. All right, bringing up the rear for me, driving a laser at 200 volts for nanoseconds is a sweet hack by Aled Kuda. He's taking one of those blue laser diodes. It looks like it's kind of a normal one. I don't know if he said what it's rated for, but I assume it's like 1 watt, 2 watts. It's a normal small laser diode. and he's building an avalanche laser driver for it that puts an ultra short pulse at 200 volts, drives about 30 to 50 amps through this thing that's meant to take one. But the trick is he does it for a very, very short pulse. So this thing's putting out 30, maybe 40 watts, but only over 10 nanoseconds. And that is the trick. You can overdrive a lot of diode laser chips as long as you don't do it for very long. You don't let them cook themselves. Everything's fine. Most of it's about building the ultra short pulse laser driver circuit, and it's based on an avalanche transistor. So he takes a transistor, runs it backwards till it just breaks down, and then it does that for a super short period of time. Pumps the 200 volts at 30 to 50 amps through this poor little laser diode and then shuts down. There are all sorts of safety things you could worry about in the circuit. And for instance, he does have an opto isolator spec'd in, but then he instead decides to leave it go and just designs, quote, a pulse generator we don't mind blowing up in place of the opto. So, if it does go wrong, it's cheap parts. He can solder them on again. It's an absolutely beautiful little board he builds and a clean build. And, everything's really sweet here. He shows it off at the end with a really nice trick. It's doing these ultra short pulses, but then he can change the repetition rate. And so he gets it tuned to about 60 hertz and then puts his camera on 60 frames per second. And you can actually see the pulses, right? You see this really short bits of beam. They end up wandering a little bit because nothing's exactly 60 hertz. Anyway, because the camera's synced to this pulse thing, you can actually see the pulse duration in flight. And they look like they're about, a few centimeters long. So you can tell that's a short pulse. Pretty sweet. Our author, Aaron Beckendorf, wrote this up, and he wanted to say external pulse generator. He typoed it for eternal pulse generator, and everybody in the comments section picked up on that, and I think that's lovely. I think it's a great euphemism. It's like the dark emitting diode, which is what you get if you run your light emitting diode to high current for too long. It becomes a dark emitting diode. I'm thinking an eternal pulse generator is what happens when you fry your otherwise ultra short pulse generator. You get it dead short, an eternal pulse generator. I've added that to my list of euphemisms.
Yeah, that's a super interesting project, and there were actually a lot of little small things in it that were interesting, like the clear solder mask, right, which made it easier to do the reflow. I thought that was, even though, so even if you're not interested in lasers, there was enough interesting pieces to this. I know somebody asked in the comments, and I thought, well, it's probably a pretty good question is, what do you do with this now that you have it? And I don't know the answer. I know my couple of laser cutters that I have now, they have more than one diode in them, and it kind of merges them together to get a better cut. So I wonder if you could do that with this. Could you have like 30 or 40 of these in a circle?
All firing together. Yeah.
Yeah. Well, in sequence, right? Boop, 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 and then you collimate the beam together. I don't know. I don't know what you would do with it. But did you have any thoughts on that? What would you do with a very high-powered, very brief laser beam? I don't know.
I mean, he's working in some science lab. They actually have a need for this device. So either I didn't catch it or I didn't pay attention. But in the end, I think he's aiming it at something and needed an ultra short pulse burst for something. I don't know what you'd use one for otherwise.
I mean, it's cool, undeniably. So, there's a lot of things I do that I really can't. It's like the robot arm in your garage, right? What do you need it for? Well,
Ultra short duration pulse laser. Yeah.
I'm in.
But poking around in lasers is one of those kind of infinite rabbit holes. If you want to get into it, I totally recommend Sam's Laser FAQ. I'll throw the link in the show notes.
Yes.
I actually poked around Sam's Laser Fact to see if I could find this pulse generator circuit in there because I had a hunch that it had probably been done already. I thought surely Sam's must have an avalanche laser driver circuit. And he did not. He had something very similar that uses an SCR actually as the trigger, but not an avalanche transistor one. So I think extra kudos to Alid for putting together a circuit I didn't find in Sam's Laser Fact. If you just want to make a quick and dirty constant current driver that won't fry your laser when you turn it on with bad spikes and stuff, Sam's Laser Fact has got you covered.
My last pick for the week is from Valgriz, and it was years in the making. It's porting a Fortran flight simulator to Unity 3D. And so Valgriz started writing some blog posts like 2 or 3 years ago, and well, 2021. So I guess that's 4 years ago. But very recently, kind of, I guess, finished it. I don't know. Maybe there'll be another one in a year or something. But he's obviously very talented with aeronautical stuff, and he bought a book, a textbook. I presume he's studying in school, maybe, or I don't know why, but he bought a textbook about aerodynamics. And on the book, there was I guess, a CD, but it was an F-16 simulator based on actual wind tunnel testing with an F-16 model. And I'm sure it was very scientifically rigorous because it's some college textbook. I looked it up. It's like $100 textbook. But here's the problem. The code was in Fortran. So he decided he wanted to do something more interesting with it. So he ported the code to Unity 3D. And this is the second example of where I think there was just some insanely good documentation going on, because if you really want to understand any of this stuff, those blog posts are just gold. They're long, they're detailed, there's stuff in them that, I don't know. I think it was all pretty interesting. Maybe if you know all about it, it wouldn't be anything new, but I doubt that. The F-16 is particularly interesting because it's a negative stability aircraft. So it's almost impossible to fly it by hand. And the problem is, because the textbook was only concerned with the wind tunnel modeling and the aerodynamics, it doesn't have the flight computer that the real F-16 uses to actually say, oh, you want to bank 5 degrees to the right? Okay, I'll do all these weird things to bank 5 degrees to the right and also correct for all the spins that are going to happen in different axes for that. So he actually got to try flying it without the controller, and he said it's virtually impossible to do. So then he wrote his own controller, which may or may not actually have anything to do with what a real one does, but my guess is they're probably fairly similar. Probably wasn't in the book, because I'm sure that at least at one time was highly classified, if it isn't still. And so he's got his own flight control computer, and this is all in Unity 3D. And if you've got the right hardware, you can actually go fly it on the web, and it seems pretty good. The code's on GitHub, but the real star, I think, is the 3 or 4 part blog posts going back a couple of years that are just insanely detailed about what he did. There were a couple of things like the PID controllers were not able to completely control the flight because it needs limiters for G-force and angle of attack. I don't know. I don't think I would have come up with that, right? I would have said, oh, the PIDs aren't working. I don't know why. So there's a lot of things you could glean out of this if you have any interest at all in flight simulation or flying or, anything more than just tooling around in Microsoft Flight Simulator. This is probably a good read. So.
Yeah, when you say porting something from Fortran to Unity is not as easy as you think. I mean,
I didn't think it was easy to start with.
It doesn't sound easy. But it's going from one domain to an entirely different one in a lot of ways. And really, what's going on is that he's learning to understand how this flight simulator and how all of its math works and everything in between, and then just kind of re-implementing it in Unity. Like, yeah, I mean, it's a port, but it's not like he's just changing variable definitions so that they work with a language that has different syntax. He's thinking hard about what it's doing and re-implementing it. And I think that's really cool about this. And I think, that's, like you say, the documentation is fantastic. The code is actually really pretty clear. If you haven't done a simulator, like if you haven't coded something up in Unity, that's kind of cool to get a look behind that curtain. Like, you don't have to be into flight simulators to think this is a cool project, but if you are, it's doubly cool. All right, my first quick hack comes from Tentech. It's another 3D print smoothing hack. We saw one a few weeks ago that was smoothing 3D prints with a heated ball end effector that he ran over the print with custom paths. This time he's like, oh, we could just take away the heated ball and hit it with a melting laser and remelt the print. So it's basically the same story. It's custom G code to make a second pass over the print, except this time it's remelting with a laser. Super cool. Alvaro Prieto, Seger's awkward USB-C issue with the J-Link compact debugger. Seger makes a bunch of awesome debuggers. People with infinite budgets swear by them. What's funny here is that they've made the USB-C mess up here the one where instead of putting one resistor from each of the two CC lines down to ground, you're like, oh, we could just share them, and they pool them together. That means the cables with an E marker choke when they see the device and won't give it any power. Raspberry Pi did this with the first revision of the Pi 4, I think it was, and we wrote it up on Hackaday. Anyway, Alvaro's built a great USB cable checker that he uses here, and this demonstrates the effect perfectly. It has like two LEDs that should light up, and one of them lights up dimly, and that's like sign number one that you have a bad USB-C device termination implementation. The other one is if it works with a USB-A to USB-C adapter, but doesn't work with a USB-C cable that has an E marker in it. This is what they did wrong. And he dissects that pretty nicely. A video from the serial port, YouTube over dial-up, they end up using 12 dial-up modems, 56K BPS modems, 12 of them in parallel, along with a home-hosted ISP, which is basically just another bunch of phone lines to call into them, for a whopping 668.8 kilobits per second. They're able to watch YouTube with it. But the video is actually a nice dive into the kind of old school phone line modems. And I thought that part was as much fun as kind of the stunt hack of ganging 12 of them together. And last but not least, Kinethreads, a low-cost haptic exosuit. I just had to throw this one in because it's so cool looking. Vivian Shen and Chris Harrison, this is kind of an experimental project. It's got a bunch of motors in a backpack running threads to your arms and your hands and your feet, giving you haptic feedback by pulling on the wires like you were some kind of marionette. But they've some really cool demos, like one where he's boxing and it's like pulling his head back and, you know, exerting force at the end of his punches and things like that. It's a really, really cool idea. It looks totally goofy, but actually, once you've got the VR goggles on, I bet it's pretty convincing.
My quick hacks this week, Lambert Satori, he's done something we've all done, which is say, gee, I've got an FPGA, and what am I going to do with it? The kind of comes back, this is the theme this week, the robot arm. What are you going to do with it? Well, one of the problems with trying to learn FPGAs is really FPGAs are super good for something, but not everything. And yet you got to start somewhere. So you do your traffic lights, or you do, you know, not really something you couldn't do with an Arduino, but you just want to have the practice. So in this case, he's got an FPGA-based mechanical keyboard, and it's got a Lattice FPGA in it, which has a USB, human interface device stack. And then he's also, because he's got the FPGA, you can just start adding other stuff into it without adding more chips. So it also has a JTAG interface, an SPI interface, an I2C interface, a UART, and an extra USB hub. So, you know, I guess that's another way to use FPGAs, is just as a super configurable piece of hardware, and that's certainly legit too. My second pick, Manish Kathuria, has Creating Python GUIs with GIMP. I saw this a while back, and I thought it was very interesting, but it's one of those things, and predictably, I think the comments were pretty split on whether it was a good thing or not, but it's one of those things, if you need it, you probably really do need it. And the idea is you can go in and GIMP, and really it wouldn't have to be GIMP, and make these images that can become user interface elements for Python code. And so if you wanted to have, say, a children's game with an elephant, and you click different parts of the elephant to do different things, well, this would be right up that alley. Now, is that really good for your next business application? Probably not, right? So I think it's like anything else. It's a tool in your toolbox, and if you really need it, I think you'd really, really like it. And last but not least, again on theme, Artifexitron had the Entron Plays Games and Music, and it's just a beautiful, I don't know what you want to call it, it's not exactly a cyber deck, but it's just a custom console, if you will. It plays video games, and it has the drum synthesizer. It's really more of a synthesis of existing pieces, but it's just beautifully done, and more importantly, like we talked about earlier, beautifully documented. I made the comment that, you know, if you think of a Heathkit manual as like a 10 out of 10, this manual's easily a 7.5 or 8. It's really quite good. For me, the case looked like one of those, what were the old Kennebec computers or whatever, what was the ones that were in Scientific American way back with the TTL chips in them. I don't know if that was deliberate or not, but it's certainly good looking box, great looking design, and fantastic documentation.
All right, that brings us to our Can't Miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week, Al Williams's Ask Hackaday, How Do You Distro Hop? I'll save you a bit of reading here. Al took the craziest way to get a new Linux distribution in place of his old one. I'll let him talk about why exactly he went down this path in a couple seconds. So, Linux, right? It's free. There are a whole bunch of different flavors. How do you know which flavor is for you? The short answer is you could try them all out, but that takes a lot of time. And if you're actually using the computer, it could be dangerous. You could lose your stuff. If you're a longtime Linux user, you have a whole bunch of configurations and a particular way of doing things that you're probably accustomed to, maybe even stuck in your habits. And switching a distro, does it mean making the new one like your old one, or does it mean appreciating the default setup for what it is? I don't know. There are a whole bunch of reasons to test out the different flavors, though. How you do that simply struck a chord with a lot of people in the comments, and I thought that was fun to read. In addition to Al's saga, which is a way I frankly would never install a test distribution over my old one, but again, I'm going to let him talk in a sec. I've always done it with just put an extra hard drive in there, install the new operating system on that one, and then, your old files are still on the old hard drive. You can kind of pull them over. That's a little bit actually in the spirit of what Al did. I thought it was really fun. A bunch of people were like, I just get a laptop and install a fun distribution on it to test it out. Hell, that's fine. That makes a ton of sense. As long as you keep kind of your system stuff and your data separate from each other, there's nothing that stops you from just putting all the data stuff on like a home NAS or something. And then you just spin up whatever distribution you want, connect to the NAS, and boom, you're at home. If you don't want it to be configured exactly like your last one. Part of me is like, oh yeah, I absolutely need these commands to be set up this way. And I absolutely, I have muscle memory built around this particular browser. I absolutely need it to be set up right. And so some of that stuff, I would have to spend the time to get it ported over to a new system. But a lot of it, like my directory with my photos, and it's just my directory with my photos. That can sit on the NAS, and you can change distributions under it left, right, and center, and none of that matters. And I think lately we've been seeing people shifting toward immutable distributions, which are kind of the ultimate in this direction, where it's locked down. You can't do a lot of the system configuration stuff you might otherwise want to / be tempted to / whatever. And it really kind of enforces this separation of your data from the system part. And that makes switching among those kind of distributions probably extra super simple. So anyway, I just thought it was really cool. I haven't swapped up a distro on a real computer that I actually use in ages, but I did set up my son's computer for him, and I'll admit I used it to test out a distribution I'd always been interested in.
Well, I'll preface it with saying that what I really wanted to do was not do this, right? That was my main goal. I really don't have a lot of interest in jumping around between distributions. I had started out ages ago with Kubuntu, and then there was a nice path to go from Kubuntu to Neon, which was the KDE official distribution, so I did that. And for a long time, it was pretty good. And I do make a lot of changes to the system. I mean, I sometimes write device drivers for things that I can't otherwise get, or, I have certain things running that outside of my user account. So the idea of just saying, well, just take your home directory. There's some problems with that too, by the way, but they're subtle. But even that isn't enough for me because I have too much other stuff just tendrilled out throughout the system. What happened was Neon's been getting a little more shaky, and they've announced, oh, we're going to come up with this new immutable KDE Linux. Neon's got one volunteer working on it, and he's doing a great job. And that's like, this is why it's been so kind of shaky lately. So I said, I really want to get off before it collapses, and it's going to be hard no matter how I do it. I've always heard that OpenSUSE, I guess, is it OpenSUSE? I don't know how to pronounce it. OpenSUSE, it's German, so I would have thought you might know. But
yeah, right.
I always heard it had a good KDE implementation, so I thought, well, I'll try that. But the problem is, I'm not going to just overinstall it over my existing system. Mercifully, I have an extremely large RAID array, almost 10 terabytes of RAID storage, and I use a fraction of it, what I did is I spun up a VM and installed the new system on it, Tumbleweed, which is the rolling release one. And I went ahead and kind of got it configured much as I could to how I like to have things configured. So I'm kind of ready to go, except it's locked up in a VM. And, I guess that's one way some people do is they just keep everything on one machine and run everything as a VM or run everything as a remote desktop. But sometimes there's no substitute for, having the GPU at your disposal and not through 3 layers of abstraction. So I said, okay, now I'm going to take and copy my entire root file system into a copy. I copied that out. So now it's static. It's not changing. It's done. Of course, I did that from a live session. Now, here's where it gets tricky. The next thing I did is I plugged KVM up and actually spun up a virtual system that looks just like my real system running Neon. So now I've got my choice. I can run the native system that I've been running for, God knows how many years. I can run my virtual old system, which is just like the one you're really using, or I can run the virtual new system. So now pretty well backed up, right? So I started to run the installer again, and I thought, I don't know why I'm running the installer again. I have a totally bizarre disk set up too, so I was really nervous the installer was just going to wipe out my disks. So I just basically went and nuked everything out of my root directory except a couple of things that aren't in the normal spaces, and then just moved over everything from the virtual machine over to the hard drive, went in and did the repair on the boot so that everything would be able to be found, and boom, now I'm booting up into Tumbleweed. The key to that, and I mentioned this in the article, is there's a way to mount these virtual disks from another Linux installation so that you don't actually have to spin the VM up to do that, right? You can just basically mount the disk and copy files around. And that worked. And of course, immediately you go, oh, I forgot about blank, right? So, okay, no problem, because I had the backup copy. And I also had, if I had to say, gee, how was that set? I don't know. It's in some JSON file that I can't figure out. Well, I could just boot the old system in the VM, open up the settings for the program and copy it down, right? Or go figure that out. So all in all, other than it just being extremely time consuming and a lot of work, it did work well and it was very safe, right? At all times I was backed up in addition to my normal backups. I was backed up. I had multiple ways to get back to where I was if I needed to get back to where I was. And sure, I've had a few places where I've had to jump in and out, but it worked pretty well. Now, should you do this? Oh, no way. You should not do this, right? I will say moving the home directory sounds good, but like say Neon uses AppArmor and OpenSUSE uses SE Linux. So immediately I had all kinds of problems involved with that, many of which were very weird, right? So log files were with the wrong permissions, and so things were erroring off, and you'd go, why did that error off? And it's like, oh, it can't write to its log. Oh, that's what it was. If you SSH'd in the first time, it would work, and it was trying to write to the journals, and then the second time you tried to do it, the journal was hung up, so you could only log in SSH once. The second time, no way. And so, of course, then you think something's wrong with SSH, so you go try to troubleshoot that for 2 hours, and then you come back and realize, oh, I don't have the right SE Linux context on the WTemp file or whatever it is. And just crazy detailed stuff. So this is not for the faint of heart, I trust me. But you'd have had the same kinds of problems if you were trying to preserve some of your home directory where you jump between permission systems, or, of course, I have NVIDIA hardware. That's always a concern, too, because it's all wacky and fragile. So anyway, kids, don't try this at home. But for your amusement, I put myself through that pain. And obviously, Elliot was amused. So
I was super amused. It's funny with your whole virtual machine system, you kind of almost reinvented DistroBox, or at least it's kind of in that direction. I was surprised nobody in the comments mentioned this. It uses Docker basically to spin up an entirely new Linux distribution in the context of your current one. So it makes it, if you're one of those people who just like, I want to install this Linux, I want to install that Linux, DistroBox is kind of the way to do it because everything's completely isolated and you can just run it up and then you can trash it and then you can run it up and trash it. It's not the full install. So, again, some of your video card stuff, that won't be useful there. I don't think it's the same as doing a completely new install.
It's probably a little safer too, because the old way to do that was to just put it in a directory and change root into it, right? But then that means it can, then it can go do awful things to you in different ways. So
that's where there's the spare hard drive. Just install it on the other hard drive and then mount your first one later if you need any of the files. Like
Yeah.
you can't hurt yourself with that one if you mount the old hard drive read only.
See, I've hoisted myself on my own petard there, though, because I have three very large high-performance disks in that RAID array. So to do that, I either have to give up the RAID array or I've got to go buy three more expensive disks. I did think about that. I thought about saying, well, I could degrade the RAID array, install on one, get everything like I want, then rebuild. It's like, yeah, that's just begging for, that's begging for a, yeah. When you get a letter from me in the mail saying my computer is permanently shut down, I resign, it's like,
Dear Elliot, I can't work. Yeah. Yeah, thanks. Yeah. And that's what it is at the end of the day, right? Is that at least for some of us, all of us who work with computers, this is high stakes stuff. And, don't do it with your critical system if you can't go back to a working state, because you'll be in for a world of sadness. I love the just take an old laptop you're not using and play around with that. I guess that's what Jenny does. So Jenny does this for us. Every once in a while, she tries out a new Linux distro, and Jenny's Daily Drivers series, shout out to Jenny's Daily Drivers. And she tries to do work for Hackaday for a week using this distribution, but she does it on an old computer that she's just got kicking around. So every time she does a new daily driver, she just completely nukes it, installs the next one, and then tries to work on that for a week and then repeats. And I think that's brave. That's like the Linux nomad lifestyle. So shout out to Jenny for doing that. And it's a fun series to read too.
I know I would do that and then go, wait, what did I do with those 10 Bitcoin? Oh,
Oh!
they were on the drive I just wiped out. Damn it.
Bought a pizza back in 2007.
Well, my pick this week is Dan Maloney's A Cut Above Surgery in Space Now and in the Future. And so really kind of an interesting idea. As you know, Dan has some background in medical kinds of things, but we really haven't had any kind of major event in space where somebody had to have an appendix taken out or, some massive limb reconstruction or something. But obviously they must be thinking about that. We talked about it amongst ourselves when Dan was planning this. And, one of the things we thought about was the Antarctica people. They obviously have the same kind of thing where they're in isolation and whatever they have on hand is what they have on hand and people get sick. Dan does point out that, one of the reasons we don't see that very much is it's still pretty hard to be an astronaut. So generally, if you're more fit to begin with, you're probably going to have less problems. Although there have been some things, and obviously there's space sickness. I guess a cosmonaut had kidney stones or when he was on Mir. So there have been, certain medical things, but nothing where you really had to do surgery. And surgery in microgravity certainly would be weird. One of the things I see a lot, like in science, I like to read science fiction, write it sometimes too, but not very successfully. But when I read science fiction, I'm always looking for things like that. And you see it a lot in the movies where they're in microgravity and they want to put a blanket over somebody. So they do. And I'm thinking, well, heat doesn't rise necessarily in microgravity. So you really want to wrap them in that blanket, but they don't think of that. So I'm sure that's the smallest thing you would have to think about. And apparently the Canadians have been thinking about this a lot. They have a Falcon 20 research aircraft, which is basically like NASA's Vomit Comet. And they put a team of 10 surgeons and made them do different procedures while the airplane was screaming down at, in a parabolic arc to simulate zero G. I was thinking, God, I hope they didn't put a panda in there or something to do the tests. But apparently they have something called a cut suit, which kind of looks like it's basically doing surgery on a mannequin, but I guess it's an anatomically correct mannequin in a good way. So whatever you had to do it in 20 seconds. So I guess they were just practicing pieces of surgery, right? So you say, okay, how would I make the opening incision? If you've seen the Star Trek movies, you can get an idea of what at least people think blood spewing out of somebody is going to look like in zero gravity, because that was a famous scene. You've got things like anesthesia. Will that work the right way? Do the gases go into your lungs the right way? There's just a lot of things to think about. I don't know that Dan really comes up with any answers, because I'm not sure there are any answers, but I think the questions raised were really interesting. And if we're really going to become the spacefaring race that many of us read about, write about, and think about, that's something that's pretty important, right? Somebody's going to have a tooth out. Somebody's going to have, like you say, kidney stones or an appendectomy or, you name it. And we obviously are not ready for that yet. And it's going to be important to get ready.
This is a, continuing series of space is hard. Nothing works in space the way you think it does, right? Like if gravity isn't holding your spleen down, what happens when you cut your spleen loose, right? Like it's going to wiggle all around funny. I didn't like there have to be like a million different factors that people just don't know about yet. And the fact that the kind of best analog to this so far is, this cut suit, this fake dummy in 20-second increments on parabolic flight rapidly descending 747. And, he writes in the article that most of the time at the end of the 20 seconds, the surgeon has to tap out, not because he can't do it anymore, but because he has to vomit. And,
Yes.
I think you wouldn't have that if you were acclimatized to weightlessness. So that's the good news. But the bad news is that it would be horrible to be the first people up there stuck, both, if you're the surgeon or person who's not trained as a surgeon having to do surgery, and as the sick astronaut. Dan also points out that they do have emergency plans for this, but they basically all involve around stabilizing the patient, getting them into a capsule, and getting them back down to Earth as fast and gently as possible and get them to an Earth hospital. And I think that's the real moral of the story here. Like, you think about people going off to the moon back in the 60s, or if people are going to go off to moon bases soon in the future, they are not going to be able to get back to Earth in 5 hours. Like, if they've got a serious problem, they are going to have to deal with it in microgravity. And I guess if you're out on the moon, it's not microgravity, but it's probably somewhere in between, and probably also a little bit weird. Plus, you get regolith in your wounds. Man, I don't want to clean that out. Owie. Like, I've taken some bad falls on a skateboard, and the worst part of it isn't falling on the ground and getting scratched up. It's trying to get the gravel bits out after the fact. Don't want to do that with regolith.
Yeah, I mean, I don't know. Dr. McCoy was able to take Spock's brain out of his head without any marks, but they had gravity, to be fair. So
Yeah, somehow, how did they have gravity on their spaceship?
artificial gravity.
Oh, well, there you go. Problem solved.
Well, if you can go faster than the speed of light, you probably solved artificial gravity a long time ago, right?
Yeah, fair enough. Fair enough. And that wraps it up for this week's Hackaday podcast. Thanks very much for listening. To follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
Keep those hacks coming.
and all that mess, super. Mr. Almost Always Wrong. Sadly, he got it wrong.
Well, statistically, you saw that coming, right? So
I'm not surprised.
or when you do want it, you got to figure out. Sorry, I thought that was on mute. I did some vibe coding the other day.
What are they called? They're E-Link, E-Cert, no, blanking on words. E-Marker. Whew. 5 modems worth of podcast.